Hi guys, today we're looking at the polar form of a complex number. The polar form of a complex number is taking a complex number z and writing it in the form of or times cos theta plus I sine theta, where or is the modulus of the complex number and theta is the argument. This is our angle from our positive x-axis measured anti-clockwise. Let's say we have this complex number, x plus yi, and we want to write it in polar form. To do this, we must find or the modulus and theta the argument. Let's label our right angle triangle first to find these values. We can see from this right angle triangle that theta is the angle from the positive x-axis to our complex number, and or is the modulus. To find the modulus, we find the absolute value of x plus yi, i.e. the or is equal to the square root of x squared plus y squared. And to find theta, we use tan of theta is equal to y over x, where y in this case is the imaginary value and x is the real value of your complex number. Let's look at an example question. Question 1. Write the following complex numbers in their polar form. Or times cos theta plus I sine theta. Let's look at part 1. To write this in polar form, we're going to follow these steps. Step 1. We're going to find or the modulus of this complex number. To find the modulus, we will label our real and our complex numbers. Our real value is 1, therefore a is equal to 1. And b, our complex value, is root 3. Our modulus is equal to square root of a squared plus b squared. Substituting our values into our formula, we get square root of 1 squared plus root 3 squared. This simplifies to 2. The modulus of this complex number is 2. We now need to find theta, the argument. To find the argument, we find tan of a is equal to b over a. Substitute in our values for b and a. This gives us tan of a is equal to root 3 over 1. To find a, our argument, we find inverse tan of root 3. A is pi over 3. Please note that your angle of the argument is always written in radians. We then use our argument to find the corresponding angle in the correct quadrant. In this case, our complex number lies in the first quadrant, and therefore our angle measured from the positive x-axis is equal to pi over 3. Therefore, our argument is pi over 3. We now take these two values and substitute them into our formula for polar form, or times cos of theta plus I sine theta. This gives us our complex number of 1 plus root 3i as 2 times cos pi over 3 plus I sine pi over 3. Here we have changed our complex number into polar form. Please note that when our complex number is in the form of a plus bi, we say it is in rectangular form. And when it is in the form of or times cos theta plus I sine theta, we say that our complex number is written in polar form. Let's look at another example. Let's look at question 5, part 4. 2 root 3 minus 2i. They have given us the complex number in rectangular form, and we want to find it in polar form. To do this, we must first find the modulus. To find the modulus, we label our real and our imaginary values. A, our real value, is 2 root 3, and B, our imaginary value, is minus 2. We substitute these into our formula for the modulus, which you can see is also Pythagoras' theorem, or is equal to the square root of a squared plus b squared. This gives us or is equal to the square root of 2 root 3 squared plus minus 2 squared. Simplifying this, we get or, our modulus, is equal to 4. That means the distance from the origin to our complex number is 4 units. We now need to find a, the argument. Tan of a is equal to b over a. The first thing we do is we find our reference angle, or we find a in the positive, in the first quadrant. That's the positive x and y axis. Substitute your values for b and a into your formula. Please note that I am ignoring the signs. When I'm finding a, I find my angle in the positive x and y axis, i.e. I find the angle for this complex number in the first quadrant. This gives us tan of a is equal to 2 root 3 over 2. Therefore, a is equal to inverse tan of root 3. A is equal to pi over 3. We use this value of a, our reference angle, to find the argument. To do this, we must draw where our complex number is. Here you can see my diagram of my complex number. Here we can see that our complex number lies in the fourth quadrant. Therefore, to find my argument measured from the positive x-axis anti-clockwise around, we subtract our reference angle of pi over 3 from 2 pi. This gives us theta is equal to 2 pi minus pi over 3, and theta is equal to 5 pi over 6. Please note, you can measure your angle clockwise as long as you change the sign. If you were measuring your angle to this point clockwise, the angle would be minus pi over 3. But we tend to avoid this in maths, and so we'll continue to measure our angle from the positive x-axis anti-clockwise. Now that we have our value of theta, let's substitute these into our formula for polar form. 2 root 3 minus 2i in polar form is written as 4 times cos 5 pi over 6 plus I sine 5 pi over 6. Okay, let's remind ourselves how we can find theta in each quadrant. To find theta in your first quadrant, i.e. the angle from the positive x-axis, we find our reference angle, tan of a, equals b over a, and we can see that theta and a are the same value. If your complex number lies in the second quadrant, to find theta, i.e. the argument, which is the angle from the positive x-axis, as you can see in my diagram, we subtract a from pi. because we want the measure of the angle from the positive x-axis, we have found this measure, so we subtract it from pi 180 degrees. If your complex number lies in the third quadrant, theta, your argument, is pi plus a. And if your complex number lies in your fourth quadrant, as shown here, theta, our argument, i.e. our angle measured anti-clockwise, to our complex number is 2 pi minus a. Please pause the video and take this down. Let's look at how we can multiply values in polar form. If we have two complex numbers and we want to multiply them when they are written in polar form, we multiply the moduli and we add the arguments. If you have two complex numbers written in polar form and you would like to divide these, to do this, we divide the moduli and subtract the arguments. Please pause and take this down.